Alright, welcome to Geometry 3-3, Proving Triangles Similar. And I just wanted to make a comment before we get started here, and that is that we've already established a definition of what similarity means, or similar means. And the definition that we've established for similar is two figures are only similar if and only if there is a similarity transformation that can map one figure onto the other. And that's our definition of similar, and I want that to remain the core of our definition. And again, that says if there is a composition of rigid motions and dilations. So I could use the rigid motion of translation to match this point to this point, and then dilate it so that these three sides are equal to each other. If that's our definition of similarity, now that we have that established, we're kind of looking at shortcuts to establish if two triangles specifically are similar. And the first way that we're looking at that is angle, angle. Just to let you know, this symbol here is similarity. Let me make this, I made a mistake here. This should just be this symbol. This is similar, and this is congruent. So again, we're just studying proving triangles similar. So we have the angle, angle, similarity postulate. And I'll read slowly here about exactly what this says, because you need to write in your definition. But it says if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. I'll read it one more time slowly. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. And that's exactly what we have here. So looking at kind of the shortcut, you could see if you have two angles that are similar, that are congruent, then your two triangles are similar. Let's look at another theorem of how we could show that two triangles are similar to each other. Alright, this one is the side angle side similarity. Again, side angle side similarity theorem. And I'll read slowly here for your definitions. This theorem says that if the angle of one triangle is congruent to the angle of another triangle, so the angle of one triangle is congruent to the angle of another triangle, and the sides that include the two angles, are proportional, then the triangles are similar. And I'll read this one more time slowly and explain what I mean by proportional. If an angle of one triangle is congruent to the angle of a second triangle, and the sides that include the two angles, so these two sides that include them, are proportional to each other, then the two triangles are similar. And what do you mean by proportional? Proportional means, and you can see we're dividing these here, if we divide that, they're going to give us the same ratio, the same proportion, the same factor. So when we divide these, if we get the same number, then that would mean that these sides are proportional to each other. So that's your side angle side similarity. All right, let's look at the last one, side side side. Side 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 similarity, and I'll go slow again. This just says if the corresponding sides, and I've just color coded these, if the corresponding sides of two triangles are proportional, then the two triangles are similar. I'll say it slowly again. If the corresponding sides of two triangles are proportional, meaning that when you divide you get the same ratio from all three sides, then the triangles are similar. Okay, so we've looked at these three theorems, and you're going to use these to verify are triangles similar. So can you find that all three sides are the same, or that they have two angles the same, or side angle side are the same. You're also going to do some proofs in here, and hopefully this video helps you along. Good luck. See you in the next one. Bye.